roaming protocol that I told you about, 802.11f, is really the basis, or it's very similar to all of the vendors' roaming protocols, but slightly different. Now, since all of the vendors' roaming protocols is secret sauce and proprietary, I can't really tell you exactly what they're due step by step. So instead, I use the 802.11 standard to make this demonstration. And here is how 802.11f roaming works, or worked. And you'll find that this is really pretty close to what everybody does. Close enough for a general understanding of how roaming works. Now, this is not fast roaming, just standardized roaming, okay? So in this case, we have no security turned on. We're not going to worry about the PMK IDs being cached and things like that. We can talk about that later on. But right now, I've got one client device, upper left corner, and it's going to associate to AP1, the one on the left, and then it's going to start moving. And as it moves, it will lose its connection with AP1 and try to roam over onto AP2. And this is how 802.11 would perform this function. So to begin with, AP1 sends out a beacon, and the client device, the iPad up here, notices, discovers the access point and sees that there's a beacon from AP1 with an SSID that matches its own, 7777. The signal is low, but it's strong enough to be able to allow us to associate, and that's all we care about at this point. So the iPad will now send a authentication request and receive an authentication response. So that's successful. The next step, as you remember, will be to send an association request and receive an association response. And since that's successful, we've now become associated. Since we're not using anything else, we're now on the network. And so now the iPad will begin an FTP session through this AP. So we start to receive data from the wired side down to the iPad. So we send data ACK, and at this point, the client device starts to move. So he's roaming in the environment. He's still getting data ACK as he moves along. But at some point, the client device moves behind an obstruction and no longer receives a signal. See, the RSSI has dropped down to none. The problem is the AP has no way of knowing that. So it will continue to transmit this frame. Remember, contend for the medium, get in the chair, transmit data. Don't get an ACK. That means we have to send it again and again and again. By default, 64 times before we give up. Meanwhile, the client device has noticed that the signal strength to the AP has dropped for some reason. And so the client will consult its list of other APs, or it will go back into discovery mode. In this case, it hears an AP from here's a second AP's beacon, and the second AP is also on the preferred SSID of 7777, and the signal strength is low, but good enough to support connectivity. And so the access point has completed discovery. It's found an AP. We don't always have to send probe request, probe response. We can just use the passive scanning method to discover an AP. And that's what we've done here. So the next step after discovery will be authentication. So the client device sends auth1, that's the request. The AP responds back with auth2. Meanwhile, AP1 is still over here transmitting data and not receiving ACKs, has no way of knowing why, just knows it's got a job to do. The iPad has been authenticated. As you know, the next step is to associate, but here's where the problem occurs. In the 802.11 standard, it's written that a client device may only have one association in place at a time. The reason for that is because an association is a guarantee from an access point to a client device that says that the access point takes responsibility for receiving and delivering all traffic to that client. So a client can't have two APs taking that responsibility, only one at a time. So now this iPad, who already has an association identifier, who already has an association in place, has to move to another AP, but it can't use the association request and response because it already has an association. Instead, it uses a reassociation request. That's another management message. Now, when access point receives a reassociation request in place of an association request, it immediately tells the access point, hey, here's a guy that's already connected somewhere else. And now the AP looks at the reassociation request message, and that will have one additional field contained inside that, at least one additional field. And that field contains the MAC address of the AP that this client device is already associated with. And so the access point takes the MAC address of the access point that this guy is connected to, and he uses that to send an Ethernet message over the wired side over to AP1 saying, hey, I got your guy over here. Your guy wants to come over and roam on to me right now. Did you know that? Well, the AP1 says, oh, okay, well, that explains why I'm not getting an ACK back from this guy. So, yeah, that's fine. If he's over there, if he wants to play in your sandbox, let him. That's fine with me. So the AP1 sends a reply back to AP2 saying, that's good. Yep, tell him he's good to go. And I'm going to remove him from my associations table, and you go ahead and add him to yours. So that's what that Ethernet message essentially said. Now that AP2 has received the confirmation from AP1, AP2 will send out a reassociation response message, successful, and then it will take over sending the data and receiving the acknowledgments. If this occurred fairly quickly before the layer 4 TCP/IP sliding window timed out, then this file transfer will continue uninterrupted. But if it took longer than the TCP sliding window's timeout value, then we probably would have, we may have dropped the connection at some point, in other words, and we would have had to restart the FTP session. Okay, but that's the idea behind roaming. Now, one other thing probably is going to occur here, and that is either the access point one or the client station, or both, may issue a deauthentication message to the air. And that's just to clear it out, and it's a matter of good form. That clears out the associations table of the AP. If somehow the client device heard that, it would know that it's been kicked off of this AP, even though it doesn't care it's connected to this AP. It's a deauthentication message and a disassociation message. Those are used in roaming, and they're really just meant to clear out everybody's associations tables. Okay, so that's essentially how roaming works in an 802.11 wireless LAN. Even though the vendors may do something slightly different, that's pretty much it. Are there any questions on that?